Good morning, honors pre-calc students. This is Coach H here with your Chapter 2, Section 1 notes. Chapter 2, we're going to focus in on polynomials, but we're going to begin this chapter by referring back to the most basic of polynomials, and that is a quadratic function. So I hope a lot of what we covered today is review for you from Algebra 2. And again, we're just setting the stage of polynomial functions to come here in Chapter 2. All right, well, let's jump into some basic just information about quadratics and remind you of a few things, all right? So first off, let's review a few things about polynomials. So when we talk about polynomial, right, the word polynomial literally means many terms, right? So when we use the term binomial or trinomial, we're saying two terms or three terms, but a polynomial is many terms, all right? So this is the form of a quadratic function in its polynomial form, right? You can see we have our descending variables or descending powers of x, right? So we have x squared, x to the first. Our constant would technically be x to the 0, right? And we know just from your past math knowledge and even from working a little bit in Chapter 1 that the graph of this function is a parabola, right? And so when we look at that parabola, a couple of key characteristics that we want to have, right? You might remember from Algebra 2 that the low point of a parabola, if it's opening up, or the high point of a parabola, if it's opening down, is what we call the vertex, right? So when we look at this, this HK point, this is representing our vertex. And then we're also going to talk about this line down the middle, right? This vertical line that's passing through the vertex. We're going to give that the name of the axis of symmetry. So let's define things here just a little bit, all right? So that polynomial form of a quadratic can be rewritten into the standard form of a quadratic. And that's what we see here, all right? And if we think about it, this form, right, which you might also recognize from your Algebra 2 days, you may have called it vertex form, right? So vertex form and standard form are kind of the same idea, right? But really, when I look at this function, it's based off of our parent function. I'm going to call our parent function g of x, right, of x squared. So when I compare the vertex form of a parabola to the parent function, we're just seeing all of the transformations and shifts that are being applied, right? I have a shift up k units. I have a shift to the right h units. I have a vertical stretch or shrink depending on what the value of a is, right? So it's just transforming our parent function, all right? And when we're given standard form, it makes it really easy for us to identify the vertex, right? The vertex is just going to be h and k. We're shifting that, again, vertex point of the graph. And the axis of symmetry is going to be based on whatever the h value is, all right? So this is a form that we're going to kind of focus on today. We're going to begin in polynomial form and really kind of want to focus on how can we find the vertex form from that. All right, that'll be the main skill that we take a look at. So with that being said, let's just go through a couple of example problems, and then we'll get you started on your homework assignment for today. But let's begin with graphing of a quadratic, right? So if I need to graph this this polynomial function, right, this quadratic function, in this form, it's really difficult for us to graph, right? We can't see, hey, what are the vertical and horizontal shifts? The only thing I can really glean from this function is that a is I've got this, vertical stretch here, and it's positive, so it's going to open up, right? That's all I know about that parabola, but I have no idea, like, where is it centered on this graph, right? Is it shifted left? Is it shifted right? Is it shifted up or down? The only way for us to know that is to have the standard or vertex form of a parabola. And so that's what we want to review here first today, is we want to walk through how do we take a polynomial form of a function and convert it into standard form. And so there's just 4 simple steps that I want to walk through with you today, all right? So we're going to first group our x's, then we're going to factor out our a value, we'll complete the square, and we'll balance, okay? And so we'll take our time to kind of walk through these, and we'll see, hey, once I have this quadratic function, it's really easy for me to graph it, okay? So let's begin with the very first step, this step of grouping our x's, all right? So I'm just going to rewrite my function here so we can work our way through it and just see everything from beginning to end. So we have 2x squared plus 8x plus 7. All right. So again, the first thing I'm going to do is I'm literally going to group my x terms. So I'm going to put parentheses around those x's, right? So the first two terms contain an x. So let's group those together, okay? And now the next thing that I want to do is I want to factor out a, right? Well, a is just the number that's in front of my squared term. So when I come down here, I want to factor out this 2, all right? So as I factor out a 2, that impacts both of the terms that are left in my set of parentheses right now. So this is going to become x squared, right? Well, if I factor out a 2 here, I'm left with plus 4x, okay? Now, I'm going to leave a little gap in my parenthesis here because I know what my next step is. Step number 3 is going to be to complete the square. So we need some room in here to complete the square. And then we'll go plus 7. All right? Now, I'm going to change colors here just for this completing the square step. All right? Just so we can kind of visualize that. So when I go to complete the square, right, completing the square is just simply we're going to take our b value, we're going to divide it by 2, and we are going to square that. All right, when we say completing the square, what we are trying to do is I'm trying to create a perfect square trinomial. A trinomial that factors into two binomials that are the exact same, right? Because my end goal here to get it into standard form is I need to have this a times a quantity x minus h squared plus k. Right? So in order for me to get this part of the vertex form, I can only create this if I have a perfect square trinomial over here. All right? So again, we're just going to take b divided by 2 and square it. So I'm going to take 4 divided by 2. So 4 divided by 2 is 2. Square that, and I'm going to add a 4 into this equation. Okay? Now, our next step then, we can't just add anything into an equation, right? We've actually changed the equation unless we balance that somewhere, right? So we think about when we're solving equations, right? We subtract things from both sides, or we add things to both sides, or we, right, multiply both sides by the same thing, right? So I need to keep this in balance. Now, here's where we have to be careful, all right, is I didn't actually add a 4 into the equation. I actually added 4 times 2. Okay, so when we balance, I have to factor in what I factored out. So 4 times 2 is 8. What I really added into this equation was I really added in an 8. So I need to balance that by subtracting 8. Right? I need the opposite or the inverse operation. That's how I keep this equation balanced. Okay? And that's important because it's going to end up impacting our k value. All right, so now at this point, let me switch back to my blue color here. We are ready to finish the standard form, okay? So as I look at this equation that I'm working with, right, we have 2, and then x plus 4x plus 4. That's going to factor into x plus 2 and x plus 2, right? So I get to write this now as x plus 2 quantity squared. That's the vertex form coming out of that perfect square trinomial, right? Then when I just add my constants back here, so 7 minus 8, I'm going to end up with a -1 on the back side. So this is the standard form of my quadratic function. Right? We began with this polynomial form, right? And through this process, we have now created the vertex form of this parabola. So now this is really easy for me to graph, right? I'm going to look at this equation. I'm going to say, hey, I know what my vertex is now, right? My vertex is just simply going to be, I've got a left shift and a shift down. So -2, -1, right, becomes my vertex. So I can come up here and I can plot my vertex. Okay. I know that this parabola is going to be opening up because A is positive. But I do recognize I also have a vertical shift, or excuse me, a vertical stretch. So this parabola is being stretched vertically 2 units. So normally when I graph a parabola, right, I go over 1, up 1. Well, now I'm going to go over 1, up 2 on each side. And normally on a parabola, you go over 2 and up 4, right, because 2 squared is 4. Well, now I'm going to go over 2 and up 8 because it's been vertically stretched 2 units. So I'm just going to kind of get these key points in here, and now I can sketch my parabola off of those points. Right? Imagine that I pass through all those points. I'm not very good drawing with my my pen here on my computer. But that's going to be an important skill. This idea of completing the square is going to be very, very important. All right. So I would encourage you, if you need to go back and watch this part again, or go back, watch again, pause it, and make sure you have down all the notes that you need. That would be a really wise idea. All right, let's take a look at a couple more examples. So one more where we have to put things into standard form, but let's look at a story problem. All right. So for my softball ladies here in pre-calc, let's say that I went to the batting cage to hit some softballs. Back in the day, I was a pretty mean slow pitch softball player. But while I was there, I had some great hits, some not so great hits. And of course, being the math teacher geek that I am, I decided to model one of my hits using a quadratic equation, right? So we've got this function in here that is representing my hit, right? Where x is representing how long in the air the ball has been, and f of x is representing the height. So the question there is, what is the maximum height of Coach H's hit, if that's the model that we are utilizing, okay? So I want to point out a couple of things right here before we even get started doing any work, right? So if I think about it right off the bat, I hope you notice that this leading coefficient was negative. So we should know, right, from last chapter, that's a reflection about the x-axis. And so this parabola is going to end up opening down. Okay, this is the path that my hit traveled, right? I'm going to have a downward opening parabola. And so the maximum height is going to occur at the vertex. So really, all we need to do in this problem is just identify what the vertex is, and then the y-coordinate of the vertex, right? Because f of x represents the height, that will tell me what the maximum height is. Because again, I have a downward opening parabola. All right, so really all I need to do is I just need to take this equation and I'm going to walk through that completing the square process again, just like we did on the last problem. All right, so I'm going to copy over my function. All right, so again, first thing we need to do, group the x's. All right, now I'm going to factor out my leading coefficient. So I'm going to factor out a negative 16. All right. If I take 48 and divide by negative 16, that's going to leave me with a negative 3. Again, I'm going to leave a little gap here because I want to come back and complete the square, plus 2.5. All right. So now let me switch colors again just so we can, I like to visualize that completing the square in a different color. All right, so I'm just going to jot that down off to the side here. Let's come over here. So completing the square, I'm going to take a negative 3, divide it by 2, and square it. All right, so if I do that, that's going to give me 9/4 as the value that I need to add in to my equation. Okay. Now again, remember, we didn't really add in a 9/4. What I really added in was 9/4 times a negative 16. Okay. So if I take 9/4 times a negative 16, what I'm going to end up with is a negative 36. Okay. So to balance that, I need a positive 36 on the outside. Right? Again, whatever I add into the equation, I have to balance somewhere, and I'm adding it this time because when I take 9/4 times this negative 16, what I've really put into this function is a negative number, all right? So let me go back and switch to my blue, and we'll finish out this problem. All right, so now if I come back to finish my completing the square process, right, I end up with a negative 16. Now, when you go to factor this, especially because there's a fraction in this, it can get a little messy, but I'm going to give you a little hint, right? This will always factor into x, and then I'm just going to take the sign that I have here, minus, and then whatever I have here, that's what I factor into, right? 9/4 is going to factor into 3/2 times 3/2. Okay, so I can just kind of go back and look at my work on the completing the square, and I automatically know how to factor that perfect square trinomial. All right, then again, I just add on back here, so we end up with 38.5. All right, now again, we said that the y coordinate of the vertex is going to represent the maximum height of my hit. So when I look at this equation now in vertex form, well, I know that 38.5, that's the y-coordinate of my vertex. So the maximum height of my hit was 38.5 feet. And again, I found that or identified that by just finding the vertex of this upside down opening parabola. All right? So there's another example of completing the square and just thinking through the characteristics of a parabola to help us find the answer to our question. All right, one final problem I want to walk through is part of your homework assignment today. I am going to give you various information about a parabola, and your job is going to be to take that information and, as it says here, write the standard form of the equation. Okay? So let's talk about this process here real quick. All right, so first off, remember that the standard form of a parabola is f of x is equal to a times x minus h, quantity squared, plus k. Right, so in order for us to write the standard form, we have three things that we need to figure out. We need to figure out what is a, what is h, and what is k. Now, there's no particular order in how we'll find these things. It will 100% be dependent on the information that we're given. All right, so if we go back to this problem, right away you should identify something that, hey, that's pretty nice, right? So they tell us that the vertex of this parabola is a negative 4/11. Well, now I know what h and k are, right? So all I need to do is plug in a negative 4 and 11 in for h and k. So at this point, I know that a is equal to x plus 4, right, minus a negative 4, since h is negative 4, so it becomes positive, plus 11. All right? Well, now what I need to figure out is what in the heck is a, all right? Well, I only have one other piece of information here, but this piece of information actually ends up being pretty helpful, right? They tell us that this parabola passes through the point negative 6 and 15. So essentially what they have just given me, they've just given me an x and a y value that lie on this parabola. So I can come back over here to my parabola, right? And just remember, f of x is essentially representing y. So I can think of my equation like this right now. Well, now I take that point and I'm just going to plug those values in for x and y, right? So now I'm going to say, hey, y, you're going to be equal to 15 because I know that has to be a value since this parabola passes through that point. I have no idea what a is, all right? X is negative 6 plus 4, quantity squared, plus 11. Well, because they gave us the vertex, we substituted that in for h and k, and because they gave us a point that we substituted in for x and y, I now just need to solve this equation for a, and now I'll know what a is, all right? So if we do that work here, all right, I'm going to go ahead and subtract 11 from both sides, all right? So I end up with 4 over here is equal to a times negative 6 plus 4, right? That would give me a negative 2, but a negative 2 squared is positive 4, right? So I end up with 4 is equal to a times 4. So I'm just going to divide both sides by 4, and I know that a is equal to 1. All right? Now, I'm not done here, right? They weren't asking us to solve for a. What they were asking us to do was write the standard form of this parabola. So I need to go back and do that, right? So we have f of x is equal to, right? My a value is 1, so I'm not even going to plug that in, right? We know that's really not necessary. Then x minus, I already know from being told the vertex that this is x plus h quantity, or excuse me, x plus 4 quantity squared, and then my k value is 11. And so this would be the standard form of the parabola, all right? So again, you're going to have some homework problems like this on your assignment today, and just going to take whatever information that they give you, and maybe they give you the vertex, maybe they give you, a point that it passes through, or who knows, different information that you'll be given, and your goal is to try and use that to write that standard form, all right? So just think a little bit. I know you guys can figure it out. All right, that brings us to the end of our lesson today. If you need to rewatch this, please do so. Again, it'll be posted in the Google Classroom. If you didn't notice, there are also notes posted in the Google Classroom that go along with this lesson, so you can access those as well. So this is your homework assignment. And just be aware, hey, you got a long weekend ahead of you. No school on Monday, so enjoy your 3-day weekend. But when we gather together again on Tuesday, you will need your graphing calculator, so bring that with you. All right, you guys make it a great day, and I will see you Tuesday.